synthesized electrolytically ethane, ethene and ethyne. At first let us start from the ethane. Ethane was synthesized from the sodium or potassium salt of acetic acid or ethanoic acid, and at first this sodium salt, this salt dissociates like that: acetate ion, acetate ion, and this is sodium metal. At anode oxidation, this terminal oxidation occurs. This acetate ion liberates one electron to give you the acetate free radical, and one electron is liberated. And now this acetate free radical, this electron moves here, and one electron from here moves here, and one electron goes to this methyl group, and to give you the CS3 methyl free radical and one molecule of carbon dioxide, you will get such two molecules of methyl free radicals. Such two molecules of methyl free radicals combines to give ethane. This is ethane. We synthesized, we can say the ethane, and at cathode terminal reduction occurs. You will get reduction, sodium ion plus electron, you will get sodium free, and this sodium free in next step react with water molecule to give sodium hydroxide and hydrogen gas. So that hydrogen gas is liberated at cathode during the electrolytical synthesis, and at anode terminal we synthesized this ethane. Similarly, ethene can be synthesized electrolytically from the sodium or potassium salt of succinic acid. Succinic acid at first dissociates like this to give the succinate ions and the sodium ions, and at anode terminal the oxidation occurs. During the succinate ions now liberate two electrons, and it becomes a succinate free radical, and two electrons are also liberated. This succinate free radical in the next step, this electron comes from here and this electron comes from here. One electron moves here. Similarly, one electron comes here, one from this bond comes here, and one electron goes to this, and again you will get free radical, and two molecules of carbon dioxide you will also get. And finally this free radical, what happens, this electron comes here and this electron comes here to make here CS2 double bond CS2. This is the ethene. Then ethene is synthesized like this, and similarly at cathode what happens? Similarly at cathode, same. At cathode reduction occurs. At cathode reduction occurs. Sodium ions plus two electrons are already we have, and this gives liberated sodium metal, and this sodium metal react with water to give you sodium hydroxide plus hydrogen gas is also liberated like this, and this happens at cathode terminal. This is a similarly Kolbe synthesized electrolytically ethyne. This ethyne was synthesized from the sodium or potassium salt of the fumaric acid, and this is sodium or potassium salt of fumaric acid. This dissociates like this, and this is fumarate ion, and this at anode terminal oxidation occurs. So these fumarate ions liberate 2 electrons, and it will give you the fumarate free radicals. And in next step, fumarate free radical. Fumarate free radical. This is fumarate free radical. This free electrons come here, and this also moves here. 1 electron goes to this terminal, and 1 electron here, 1 electron from here, and 1 electron goes here. You will get carbon double bond carbon free radical plus 2 molecule of carbon dioxide liberated, and in last step, this free radical, this electron comes here, this here, and we get the Ethyne, which is acetylene, or we can write this acetylene like this: acetylene, ACETY, acetylene or Ethyne. And this Ethyne was synthesized at the anode terminal. Similarly at cathode, the reduction occurs, and at cathode terminal, sodium ions with 2, already we have the 2 liberated electrons. You will get the free sodium, and this free sodium again react with the water to give you sodium hydroxide plus hydrogen gas is liberated. In this way, this at the cathode terminal reduction occurs, and we get the hydrogen gas. In this way,